Now let's find the GCD for these three polynomials. So as you can see, the lowest power among a square and a cube. Just consider these three. It is a. It is a. The lowest power among b square, b cube and b is b. The lowest power among c cube, c and c square is c. There is no constant term before, so there is no number before this. So the GCD of the above three polynomials, the GCD of the above three polynomials is just ABC. So I hope it's very clear. Just take the lowest power and then form the greatest common divisor for all these three polynomials. Now let's look at the next one. Now let's look at the GCD of the following new problems in question number 2. So let's take 2x plus 5 and 5x plus 2. So already they have been factorized of the form 2x plus 5 and 5x plus 2. Can we extract any more factors from this? Is it possible to extract any more factors from this? No, it is not possible. So nothing we can extract from this. We cannot modify this into suitable terms. So the GCD is 1. Because we cannot further factorize this, we cannot split this, we cannot extract any number out of this, which means the GCD is going to be 1. So I hope this is very clear. Let's look at the next problem, which is a power m plus 1, which is a power m plus 1, a power m plus 2, a power m plus 3. So this can be written as, this is very interesting, a power m multiplied by a. So which is actually 1. So if you add this, it becomes a power m plus 1. This can be written as a to the power m multiplied by a to the power 1 into a to the power 1. And this can be written as a to the power m multiplied by a to the power 1, a to the power 1, a to the power 1. Now what is common in all this? Between all this, what is common? What is the common term in all these three polynomials you can split? A power m is common, right? And a power 1 is common. A power m into a power 1. So if the powers are in multiplication, so you will have to, when you combine, the powers get added. A to the power m plus 1. So the GCD of a power m plus 1, m plus 2, m plus 3 is a to the power m plus 1. This is the GCD. I hope this is very clear for you. So the trick is to split whenever you have a polynomial expression as a variable plus 1. The trick is to split them into two base values and then put the powers that are in plus here, and then you make the base values get multiplied, and then you can find the common factor among them. Hope this is very clear. Now let's look at the problem 2a square plus a and 4a square minus 1. 2a square plus a, 4a square minus 1. So if you factorize this, it will become a into 2a plus 1. Interesting, right? If you factorize this, take a out, it becomes 2a plus 1. But if you look at this term, what comes to your mind? There is a minus here and there is a square here. What identity comes to your mind? Can you just close your eyes and think, or just talk to your friend and think about it? What comes to your mind? I hope some of you have guessed it right. It is a square minus b square equal to a plus b into a minus b. So how do you factorize this as a square minus b square. 4a square minus 1 will be 2a power whole square minus 1 square. And this is a, this is b. So a is 2a and b is 1. Now if you write this as, now 4a square will become, so a is 2a, which will be 2a plus 1 into 2a minus 1. Now here you have 2a plus 1 and here you have 2a plus 1 into 2a minus 1. Now what is common in between these two? A into 2a plus 1, comma, 2a plus 1 into 2a minus 1. What is common between them? The common between them is 2a plus 1. So I hope this is very clear. So what did I do? I just factorized the first term into a into 2a plus 1. And then 4a square, I use the identity a square minus b square is equal to a plus b into a minus b. And then factorized this as 2a square minus 1 square, which will be 2a plus 1 into 2a minus 1. And then I wrote this as two terms are taken separately and then the GCD is 2a plus 1. I hope this is very clear. Now let's look at the other problem. 3a square 5b cube 7c power 4. We have done this before in our previous problem. So if you look at this, there is nothing in common between 3, 5 and 7. So what is common? It is just 1. Is there anything common between a cube, b cube and c power 4? No, nothing is common. So GCD is 1. You can actually write the reason as there is nothing common. There is nothing common between 3, 5 and 7 and a square, b cube and c power 4. There is nothing common, so the GCD will be equal to 1. Okay, let's tackle the next problem, which is problem number 5. So by looking at this, you would have now understood what we are talking about. So did you guess this? Which is again the same identity, a square minus b square is equal to a plus b into a minus b. Now how do you factorize x power 4 minus 1? How do you factorize this as a square minus b square? Can you tell me? Can you think about this for a minute? Or maybe for 10 seconds? I hope some of you found that, which is x square the whole square minus 1 square, which will be a. So here it is a, this is b. So what do we write here? X square plus 1 into x square minus 1. So this is the term of. Now still something interesting. How do you factorize x square plus 1? X square minus 1. This is a, this is b. Can you write this as x plus 1 into x minus 1? Yes. Why? Because x square is, here it is x square, x the whole square minus 1 the whole square, and a is x and b is 1. So which is again factorized as, is this clear or should I write it one more time? X square minus 1. Here you can write this as x to the power whole square minus 1 to the whole square. So this is a, this is b. So which is actually split again as this. I hope that is very clear for you now. Now please understand, we have split this term as x square plus 1 into x plus 1 into x minus 1. Now how do you split this term? X square minus 1 is equal to x to the power whole square minus 1 to the power whole square. This is a, this is b, which will be x plus 1 into x minus 1. Now this is x plus 1 into x minus 1. What was the previous term? x square plus 1 into, this is the first term, this is the second term, x square plus 1 into x plus 1 into x minus 1. Now what is common between 1 and 2? What is common between 1 and 2? The common between 1 and 2 is x plus 1 into x minus 1. Is this clear? The GCD between x power 4 minus 1 and x square plus 1 after doing the necessary factorization will be x plus 1 into x minus 1. Now let's do the last problem, which is slightly difficult. Now let's do the sixth problem now, which is a cube minus 9ax square and a minus 3x the whole square. Now if you take the common ones, which is a here, a into a square minus 9x square, and we can write this as the same, a minus 3x the whole square. Now let's look at this. Can you look at this and see what is inside this? Can you make this as a factor? What comes to your mind? Now, if you do continuously problems of this nature, so when you look at a term, you will be able to factorize that. So it requires a little bit of practice. So we can say a whole square minus 3x the whole square. And now we have written this of the form a square minus b square. A square minus b square, this is a, this is b, which will be a plus 3x into a minus 3x. Is that right? A plus 3x into a minus 3x. And a minus 3x the whole square can be written as a minus 3x into a minus 3x. Now what is common between this and this? The common between this is a minus 3x. So GCD is a minus 3x. So the trick is just to factorize this term, take a out, and then it becomes a square minus b square. A square minus 3x, you write this as a square minus b square form, which is a plus b into a minus b. So a is here a and b is 3x. So a plus 3x into a minus 3x. We have factorized a cube minus 9ax square as a into a plus 3x into a minus 3x. And a minus 3x is just a product of these two. So you don't have to split it as a minus b whole square. Don't do that. You just keep it as such, and then the GCD will automatically appear. So this is the GCD between these two terms. Hope this is very clear. Let's find the GCD of the following polynomials. Let's attack the first one, P5, P11, P9. As you can see, the common factor in all this is P. If you take the powers of P, it's 5, 11 and 9. The lowest power of all this is P to the power 5. So the GCD of P5, P11, P9 will be P power 5. So we have to take the common term in this, which is P, and then the lowest power of all these three is 5, 11, 9, which is 5, and the GCD is P to the power 5. 4x cube, comma, y cube, comma, z cube. So if you look at this, 4 can be written as 1 into 2 into 2 into x cube, and this is y cube and this is z cube. But if you closely watch these three polynomials, you will see that there is nothing common in between them. So is there anything common between x, y and z? There is nothing in common. So the GCD is 1. right? The greatest common divisor is going to be 1 for the polynomials 4x cube, y cube and z cube, because there is nothing in common and there is no constant number or there is no coefficient for y cube and z cube. So the GCD is 1. Let's look at the third problem, which talks about 9a square b square c cube and 15a cube b square c to the power 4. So if you take 9 for example, if you divide it by 3, so you get 3. If you take 15 for example, if you divide it by 3, you get 5 and 1. So what is common between these two? So definitely the common between these two is 3. Now if you consider a square and a cube, the lower power is 2. So we'll take a square. If you consider b square and b square, both of them are the same, so we will consider b square. If you take c3 and c power 4, what is the lower power between c cube and c power 4? It is c cube. So you can see thus that the GCD of 9a square b square c cube and 15a cube b square c power 4 is 3a square b square c cube. I hope this is clear. So the GCD will be 3a square b square c cube. So you can make a note of this. So the idea is, first take the constant and divide it by its factors and find the common factors, right? And the greatest common factor is 3. That's the common factor between 9 and 15. And then among the polynomials, find the lowest power of each of the variable here. The lower power of a square and a cube is 2, so we have taken a square. The lower power of b square and b square, since both are the same, we have taken b square. The lower power of c cube and c power 4 is c cube. So the greatest common factor between 9 and 15 is 3, and the lowest power among all these polynomials is a square, b square and c cube. So we get the answer GCD 3a square, b square and c cube. So I hope you have made a note of this. Let's tackle the fourth problem, 64x cube 240x to the power 6. So we have 64x cube 240x to the power 6. So if you take 64 and you divide it by 2, you get 32, you get 16, you get 8 and you get 4, 2 and then 1. Similarly, if you take 240, if you take 2, it is 120, it is 60, 30, 15 and then you will have 5, 3. So you have this. Now 1, 2, 3, 4. So here there are 4 2's which are common between these two. 2 into 2, 4, 4 into 2, 8, 8 into 2, 16. So there are 4 2's between 240 and 64. So these 4 2's are common. That is the highest common factor, which will be 16. So I hope you understood how we calculated the HCF between 64 and 240. So we kept dividing by 2, the successive division, and then took the common numbers between 240 and 64, which is 16. And then if you consider the polynomial term, 64 and 240 we got 16, but if you consider x cube and x to the power 6, the lower power is x to the power 3. And so the GCD is 16x cube. But if you look at this logically also, if you take x cube, then only x cube will be able to divide this. So x cube by x cube will become 1, x power 6 by x cube will become x to the power 3. If we had chosen x power 5 as the GCD, then 64x cube by x power 5, it would not be possible to divide. So that is the logic behind choosing the lower power of the polynomials, right? So the GCD is 16x cube. So this makes it very clear. Now let's find the GCD of these three polynomials: 35x power 5 y cube z power 4, 49x square y z cube, 14xy square z square. Now if you consider these three, 35x power 5 y cube z power 4. So if you consider 35, you can actually split this as 1 into 5 into 7 x power 5 y cube z power 4, and then 49 can be split as 1 into 7 x power 2 y z cube, and 14 can be split as 7 into 2 x y square z square. Now please watch this carefully. If you want to find the greatest common factor between these three numbers, so what will be the greatest common factor will be, what is common first? The common is only 7. Okay, so 7 can divide all these three constant numbers. So 7 is common, and then if you consider x, the lowest power x here is x to the power 1, and if you consider y cube, y and y square, that will be y. If you consider z to the power 4, z to the power 3 and z to the power 2, it will be z square. So the GCD is 7xyz square. The GCD will be 7xyz square. I hope this is very clear. Let's look at the GCD of these three polynomials: 25ab cube 100a square bc, 25ab cube c 100a square bc, 125ab. If you look at the common, so let's take 25. For 25, it will be 5 into 5. For 100, you can do it as 5 and then another 5 and then 2. And then if you consider 125, again 5, again 5. So if you consider all these three, you will see that this is 5 into 5 into 1. This is 5 into 5 into 2 into 2 into 1. This is 5 into 5 into 5 into 1. I hope this is clear. So the common will be 5 into 5. And 5 into 5 will be 25. So 25 is the greatest common factor among all these constant numbers. And then if you look at there is only AB here. So here it is b cube and then here it is a square. So the lowest term for a is just a, and for b it is just b. But please also look at, there is no c term here in 125 ABC. So we cannot take the GCF as c, because if we choose c also here, then we cannot divide it from this polynomial 125ab. So here there is only ab. So the final answer will be 25ab. GCF will be 25ab. So I hope this is very clear why we didn't choose C term also in 25ab, the final answer, because it won't divide 125ab. It will still divide this and this, but it won't divide 125ab. So the final GCF answer should not consist of C. Now let's look at the final problem, which is 3ABC 5XYZ 7PQR. Actually, this is very tricky. If you consider these three numbers 3, 5 and 7, what is common between them? You know what is common? It is 1. Because you cannot divide all the 3 by any number, so it's going to be 1. Then here you have ABC, which is not present in both of this. Here you have XYZ, which is not present in both of this. Here you have PQR, which is not present in both of this. So there is nothing common in terms of a polynomial. So the tricky answer to this tricky question is GCD is 1. I hope you are also able to understand why it is 1, because there is nothing common which can divide all these three numbers 3, 5 and 7. If it was 15, we could have said still there will not be any common. If this was 15 and this was probably 18, we could have said 3 was the number which is common, which will divide. The greatest factor among all these. So what is the greatest factor between 3, 5 and 7? Nothing, it's 1. And there is no common between these three polynomials. Probably this is deliberately chosen so that you get slightly confused and look for a different answer. So there is nothing common between ABC, XYZ and PQR, so the GCD is 1. I hope it's very clear. Thank you.